Hello students, I am Mrs. Neela Kauthekar, Assistant Professor from PS Modern College of Engineering. Today we are going to learn source transformation. So what is source transformation and why we need source transformation? Source transformation is a technique in which one source is transformed. Transform means we are going to convert that source into other based on the requirement. This we need while solving the network problems. So how many sources are there? Basically, there are two sources, voltage source and current source, which we are going to use in our networks or circuits. So ideally, we think that voltage source means it is having only voltage. But practically, each voltage source is having its internal resistance. Theoretically or ideally, we are going to consider that voltage source do not have its internal resistance, or you can say voltage source is having internal resistance 0. But it is having internal resistance and which is in series with the voltage source. As it is in series with the voltage source, we are going to denote it by RS. So this is the practical circuit of voltage source. Similarly, another source is current source. Ideally, we are going to consider that current source do not have internal resistance, but it is having internal resistance and which is in shunt or parallel with the current source. So we are going to denote it by RSHs. So we are having these two sources, voltage source and current source, and we are going to transform either voltage source to current source or current source to voltage source depending upon the requirement. So how we have to transform, we will see. So this is a voltage source which I have connected to the load resistance. We can see that this is the load resistance. This means that this voltage source is connected to the load resistance. So now I want to convert it to the current source. So this internal resistance RS will go in parallel with the in case of the current source. So this voltage and resistance we are going to convert to current and its internal resistance. So while converting this, what we want, the output should not get affected. Output should not get affected means the current flowing through the RL should remain constant even though I change this voltage source to the current source. Okay, so this is our first circuit, that is the voltage source is connected to the RL through its internal resistance RS. So in this loop, current flowing through the RL is having value IL. How we are going to calculate? So this voltage, it is connected to two resistors which are connected in series with each other. So value of IL will be V divided by total resistance is RS in series with RL. So you can calculate the value of load current IL is equal to V divided by RS plus RL. Now in the new circuit, we will find out the value of IL. So this is current source means current I is going to flow here from this branch. And the I is divided into two parts. One I part will flow through the RSH, we will call it as ISH, and another part is going to flow through the IL. So using current divider rule, we can find out the current flowing through this branch. So how we will find out? The current IL flowing through the RL is RSH divided by RSH plus RL into I. I is this current, the source current. So ideally what we want that even though we convert voltage source to current source, the value of IL should not change. This means that the value of IL this first in the first equation should be equal to the value of IL this IL. So this both should be equal. Then and then we can successfully transform one source from to the another source. So now in this we can see that when it should be equal means the denominator should be equal and the numerator should be equal. So what is denominator? Denominator here is V and here denominator is I into RSH. Similarly, the numerator should be same. This means that RS plus RL it is equal to RSH plus RL. So in this equation, RL is present in the both the sides. So you can cut the value of RL and you can say that RS is equal to RSH. So whatever transformation you are going to do, the series resistance RN's value is will be the value of RSH, or you can say that series resistance value you can replace by the RSH. Only thing is here it is in series, it is connected, it is we have to connect in parallel. Now we will see this equation, the first equation. So V is equal to I into RSH, and already we have find out that value of RSH is same as RS. So you can write this equation as V is equal to I into RS, or you can say the value of I which you are going to put after the transformation, it is equal to V by RS. So this is the simple way to convert the voltage source to current source and current source to voltage source. While converting the voltage source to current source, I will be V by RS and RS is equal to RSH. While from converting the current source to voltage source, you can say that V is equal to I into RS and RS is equal to RSH. So this is the source transformation. So simple example we will see for the transformation. This is the 20 volt supply with internal resistance 5 ohm and which is connected in series with this, and I'm going to convert this to the current source. So voltage source we are going to convert to the current source. So how we are going to convert it? See, what was the equation? I is equal to V by RS. So it will be V by RS, that is 20 by 5, 4 ampere. So value of I will be 4 ampere. And this is RSH which is equal to RS, that is 5. So it is converted. Now how and where we are using this source transformation. How to transform? We have seen the equation as well as example. So this is a circuit which we want to analyze using the source transformation. So in this circuit, we want to find out the value of current flowing through this 4 ohm resistance. So using source transformation, we are going to analyze the circuit. So in this circuit, what we can see, this is a voltage source in series with the resistance. So we can convert this to a current source in parallel with the resistance. So we are going to convert it using the formula I is equal to V by RS and RSH is equal to RS. So we are going to convert it. So here what will be the value of I? 30 by 5, that is 6 ampere, and RSH is equal to RS, that is 5. So this 6 ampere and 5 ampere. So this circuit I have converted to this circuit using the source transformation method. This is the first step. Now in this circuit, what we are going to do? We are going to calculate the equivalent resistance because this 5 ohm is in parallel with 20 ohm. So how you are going to calculate this? 5 parallel with 20 means 5 into 20 divided by 5 plus 20. So 100 divided by 25, that is equivalent resistance of this is 4 ohm. Okay. Now here if you observe, you can see that a current source in parallel with a 4 ohm resistance, that is I and RSH. Now you can convert these to a voltage source. So how you can convert? V is equal to I into RSH and RS is equal to RSH. Means RS will become 4 ohm and V means 6 ampere and 4 ohm. That is 6 fours are 24. So we can convert it into a voltage source 24 volts and 4 ohm. The further circuitry going to be as it is. Now these two 4 ohms are in series with each other and you can calculate the equivalent resistance. So what will be the equivalent resistance? It is 8 ohm. This 4 ohms resistance is going to be as it is and this is the 24 volt source. Now this is become a simple circuit. The simple circuit and you can calculate the current flowing through this. It is voltage divided by total resistance. Total resistance is 8 and 4 means 12. So 24 by 12 is 2 ampere. So this circuit you have converted to a small circuit using the source transformation method and you can analyze the circuit and you can calculate the current flowing through the 4 ohm resistance. See, there are various methods to calculate the current flowing through the load resistance. But this method we are going to use, so we have analyzed using this method. So this is all about source transformation. I hope you have understood this. Thank you.